All right, well, hi everyone. It's day one of online teaching. I know y'all are super pumped. Okay, we're going to get through this. So what's going to happen with these lectures is I'm going to lecture like I would have normally in class. I'm very, very hopeful that you're going to take notes as you normally would, because taking notes really helps you, maintain it, the information and understand the information. So I really, really make sure you have your notebook out and go ahead and take notes. So let's just get right to it. We're going to look at section 7.1 today. We finished chapter 6 before spring break. So we're going to move on to chapter 7. And so we're going to kind of revisit a topic that we looked at a while back. We didn't necessarily call it a normal curve. We called it a bell curve, but that's kind of similar to what we're going to look at today. So before we get there, though, let's come up with a definition. So we're going to be looking at a lot of these types of curves here over the next few weeks. So let's talk about what a probability density curve is. This is just a curve used to describe the distribution. Distribution means how it's laid out of a continuous random variable. Remember, continuous random variables can take on any value in an intersection, okay, or in an interval rather. Okay, so I'm going to show you a picture of this in a minute, but first let's talk about some qualities of the probability density curve. The area under the curve is always 1. And by the way, that 1 corresponds to 100% because it's a probability curve. Okay. The second thing is that the area under the curve between two values, let's just call those values A and B, has kind of dual meanings. It has two different meanings. Can't spell meanings apparently. The first meaning is that it is the proportion of the population between those two values. So it's the proportion of the population. Remember, the population is the whole big group, right? So it's the portion of the population whose values are between A and B. Explanation 2 is that it is also representative of the probability that a value would be in between your two values. So it's the probability that a randomly selected individual would fall in between those two values, A and B. All right, so let's look at an example. I'm going to want you to draw this curve, and we're going to talk about why it's a probability density curve. So let's say that I'm going to give you a probability density curve of GPAs of seniors at a large university. Okay, so let's go ahead and come up with a probability density curve. Okay, now a probability density curve, let's not make this a perfectly symmetrical curve. So let's say that the lowest GPA of somebody who's going to graduate is a 2.0. And then obviously the highest GPA we can have is a 4.0. But then let's put in some other kind of benchmark GPAs. Okay, you're not graduating college with less than 2.0, okay, because that's like the bare minimum. So a probability density curve might look something like this. And again, try not to make it symmetrical. So it doesn't need to be, it could be, but it certainly doesn't need to be. Okay. So in other words, this is a curve that explains, right? There's just a few people that are at the 2.0 range, right? And there's kind of a few people that are at the 4.0 range, okay? So what I want to do, I'm going to use kind of different colors here, is let's say that I want to talk about how many people are in this area. Okay, and let's say that I tell you that the area of this section is 0.67. Okay, again, it's not a bell curve, so normally if it were in the middle, it would be half, but this curve isn't symmetrical, so it's not going to work out that way. Okay, and then maybe using an even different color, let's say that I'd also tell you that this area, the people between 3.0 and 3.5, that this area is 0.24. Okay, so with these values, I want you to answer the following questions. So the first one is find the proportion of seniors whose GPA is between 3.0 and a 3.5. Okay, so in this question, I'm asking you for the proportion, which is one of the two things that this probability density curve gives us, right? It gives us the proportion of the population whose values are between two values, or the probability. Okay, so notice if I want to know this, right, that's what I'm asking you about. I'm asking you about what's the proportion in between 3.0 and 3.5. The answer is just simply 0.24, the given area that I gave you there. Okay, so that's one interpretation of area. It's the proportion of, in this case, seniors whose GPA falls between those two values. Okay, so what about the second form of the question? What if I asked you to find the probability that if I just randomly close my eyes and point out a senior, what's the chances that that randomly chosen senior will have a GPA that is greater than 3.5? Okay, so notice I'm asking you about this area, okay, and I didn't give you that area, but because of what we know about probability density curves, okay, we should be able to figure that out, right? Because the area under a probability density curve has to be 1. So all we really have to do is do 1.0 minus the other two areas that I already knew. So I get 0.09. Okay, notice the second question asks for probability. Okay, so it's either the proportion between two values or it can be the probability that a randomly selected value would lie under that curve. Okay. All right, so that's just a general probability density curve. But a lot of things in statistics follow a very specific probability density curve called a normal distribution. Okay, so a normal distribution is a special kind of probability density curve. With the following properties. Number one is there's only one mode. Okay. Number two is it needs to be symmetrical. So the graph that we looked at in example 1 would not have been a normal distribution curve because it wasn't symmetrical. And the third requirement is at least reasonably slow. So the mean, the median, and the mode are one and the same. In other words, the average is equal to around the middle, and we expect the middle to be the most frequent option too. That's what mode means. Okay, so Said another way, we basically are going to have a bell curve. And we've already been practicing this before the break, okay? So remember, a bell curve looks like this, okay? And we have mu in the middle. It peaks in the center, and then it goes kind of out from there, okay? You do need to try to make your bell curve look symmetrical, because a true bell curve really is symmetrical. And then what we can talk about is we can talk about going out a certain number of standard deviations. So we might not have written it like this before, but this would be mu plus a standard deviation, and this would be mu minus a standard deviation, okay? And what we talked about before is that if we want to know what percentage of values are held in this interval, it is 68%. So do y'all remember the 68%, 95%? We're going to go one more on this one. You can go out another standard deviation, so this would be like mu minus 2 of the standard deviations. This would be like mu plus 2 of the standard deviations. Okay, and if you go out this far, you're going to catch, I'm going to kind of do it like this. So if you go all the way out 2 standard deviations, you catch 95% of the values. And then finally, if you go out 3 standard deviations, we talked about before the break that we would consider that we had almost all of them, and we're going to be more specific here. So if we go out 3 standard deviations, sorry, that should be a minus, change that to a minus. If you are able to go out that far, so I'm going to do it down here, then it's 99.7%. Okay, you catch 99.7% of the values. Okay, so in other words, I'm going to try to write this. Approximately 68% of the values are within 1 standard deviation of the mean. Right around 95% of the values are within 2. And then finally, 99.7, which we used the term almost all before, but we're going to be more specific now. 99.7% of the values are within 3 standard deviations of the mean. In other words, we're not going to have a very good chance of being outside of this. There is a chance, but it's not a very good one. Okay, if you think about it, there's a 0.3% chance that we're outside of that window. Okay, so we're going to revisit something else here as well. So before the break, we talked about something called z-score, and I told you that while we were just finding z-score out in the lessons before this, we would be using it a lot. So here's where we begin using it. A z-score is specifically how many standard deviations away you are from the mean. So I think we did like a lunch cost example when we first started talking about z-score. So the z-score here would be 1 because we're out 1 standard deviation. The z-score here would be 2 because we're out 2 standard deviations. The z-score here would be 3. The z-scores here would be -1, -2, and -3 because we're respectively out 1, 2, and 3 standard deviations from the mean. All right, so just maybe a little bit more on z-score. The mode has a z-score of 0, because remember the mean, median, and the mode are all the same. They're all in the middle. Okay, and negative z-scores are to the left of the mode. In other words, they're less than what we expected. And positive z-scores are to the right. Okay, so we're going to begin using a table. Okay, so you need to get out your table A.12. It looks like this. okay? Don't let the look of this overwhelm you, okay? Okay, so if you look at this, these are going to all be probabilities. If you look at the front part, everything is, we only go up to 0.99 at the bottom. Okay, if you flip it over to the back, they're smaller values. But these are all representative of probabilities. If you look at this table as a whole, notice all the tables are less than 1. So we're going to use table A.2. So you need to have this table kind of handy. Honestly, for the next few weeks of lessons, we're going to use it that much. All right, so we're going to use the z-scores given to find the appropriate areas. Okay, I'm going to give you a hint here. The table always reads less than the z-score. So in other words, we're always finding the area to the left. Okay. All right, so let's look at some examples. And again, I'm going to try to put the table up when we need it, but you need to have that out really for the remainder of the notes. So let's say, I don't really want to give a really detailed, but let's say that you had a probability density curve that looks like this. So notice I made it a little taller. We're going to put a z-score of 0 in the middle. Remember, 0 is square in the middle. Okay, and then we're going to mark a couple of values. So I'm going to mark a z-score. So let's say this is representative of z-score here. So let's say this is a z-score of 0.42. And then a little bit further away, let's say this is negative 1.45. Okay, so I'm picking z-scores that are not whole numbers purposely, actually. Okay. All right, so let's see if we can use the chart. I'm going to show you how to read it. So first I want you to find the area to the left of z equals 0.42. Okay, it's significant which direction they tell you to go. Okay, it says to the left of that z-score, and the chart, remember what I said, it always reads naturally to the left. Okay. All right, so let's kind of draw what's going on here, and we can kind of erase it if we need to. What I'm asking you about is here's 0.42, and I'm asking you to tell me what this area is. Okay, by the way, what's the overall area of everything under the curve? That's 1, right? So you can never have an area that is over 1. Okay, so that's what I'm asking you for. And how we're going to tell is you look at your chart. So I'm going to put the notes back up in a minute. So we're trying to find a z-score of 0.42. So notice we have a z here. So first you find the 0.4, and notice I'm pointing it out right here. And then up top is where the second digit of the decimal comes into play. So 0.42, you scroll your finger over to the 0.02, so it's literally 0.42, and then you read the value that is listed there, okay? Notice the value is 0.6698, so the area is what we're reading off of that chart. Okay. All right, so let's look at another one, and we'll get out the chart again if we need it. So let's find the area to the left of z equals negative 1.45. So I'm going to take my pencil here and erase it. So this time I really only want this area, right? Now my picture may not be perfectly to scale. So this is the area I'm asking about. Notice it's a pretty tiny amount. Okay. It is important that it says to the left because the chart always reads to the left. Okay, so what we're going to do is we're going to flip the chart over, okay, because notice on this side of the chart, the front part, all the z-scores are positive. If you flip it over, the z-scores are negative, right? So notice, remember our negative z-score was negative 1.45. So we're going to find negative 1.4 first, which is here, Okay, and then we're going to go over till we get to the 0.05, which is right here. So it's the value 0.0735. Okay, so let's switch it up. So notice, what if I asked you about some of these values to the right? Notice the chart's always going to read to the left, so how can we figure out areas to the opposite side? Well, if you remember that the area under the whole curve is 1, then you should be able to use the rule of complements that we use for probability. Okay, so notice I asked you for the area to the right of 0.42. Okay, so in other words, since it normally reads to the left, I'm going to need to do 1 minus whatever value I find. Okay, now again, we already found this value, right? But you could use your chart again, but we found the value that was to the left here. So you're just going to do 0 minus the 0.6628. So it's 0.3372. So what about this one? What if I ask you to find the area between the two? So between z equals negative 1.45 and z equals 0.42. Okay, so if we want to be able to refer to the picture, notice I'm getting rid of this value, right? And I actually just want everything in between. So I want everything here, here, and all of this basically. Okay, so notice this gives me the area to the left, including this little wedge that I don't want to include in my answer. This gives me the little wedge, right? So how could I find the area between the two? If you can tell by looking at the graph, we're just going to subtract the two. In other words, I want to take all of the area to the left of 0.42, but I want to take off this little wedge right here because I don't want to include that area to the left of negative 1.45. So if you subtract those out, you get 0.5892. Okay, so what that means is you can say with certainty that you would have a 58.92% chance of having values in between these two z-scores. Okay, so z-score describes how far away from the mean, the mode, and the median that we are, and then the chart tells us and transfers that into probability basically. Okay, and if you wonder where the chart came from, it actually came from doing an integral in calculus. Okay, so maybe you didn't wonder that, but that's where it comes from. Okay, that's where the people that made the chart for us got those not random at all probabilities. Okay, so I want you to find the following, and I want you to just practice using the chart. So I want you to find the probabilities to the left of z equals 1.02. Okay, now you can draw that if you like. If you are a more visual learner, you can certainly draw these every time, but it's going to get a little tedious if you have to draw it each and every time. So hopefully you can kind of maybe look up here at this graph, right? 1.02 would be maybe about here-ish, right? Like it'd be over here. And so we're trying to find the value to the left of 1.02. So if it's to the left, you have to tell yourself, okay, I can just read the chart as normal. Okay, so I'm going to take the chart out, and I'm going to find 1.0 first on the positive side, right? And I'm going to scroll my finger over until I get to the 0.02, so it looks like it's 0.8461. Okay. What about this one? To the right of z equals negative 1.55. Okay, so again, if we wanted to go here, right, negative 1.55 would be a little bit past negative 1.45 on the left, but we're trying to go to the right. We're trying to go this way, so it's going to include a lot of it, right? So the fact that they said to the right of does mean that we need to do 1 minus whatever we read on the chart. Okay, so negative 1.55, if you take your chart back out again, so find negative 1.5, and then scroll your finger over to the 0.05, and notice it's 0.0606. which is 0.9394 if you use your calculator. Okay, in other words, it's a pretty big possibility because remember, if you kind of visualize that using this thing up here, everything to the right of negative 1.55 would have included a whole big portion of this curve here. Okay. By the way, there's also something else you can do. Notice I wanted to the right of negative 1.55. A little trick you can use is because this is a symmetrical graph, you can go to the left of 1.55 positive. So you can go the opposite direction and the opposite sign. And notice if you read 1.55 directly, you get the exact answer we got, right? 0.9394. Okay, so that's another way you can do it, but really you're subtracting from 1 as long as it's to the right. All right, so what about this one? What if I asked you about between z equals negative 1.93 and z equals 0.59? Okay, so notice I'm asking you to go between two values, right? So you're going to have to find two different values on the chart, and you're going to need to remember that this one's to the right. Okay, so this one's going to be a bigger number, right? Because we're going to the left of 0.59. So again, if you visualize that, we're going left of maybe something about here-ish. Okay, as opposed to this would be to the left of negative 1.93, which is really pretty small, right? So you're going to look at your chart for both values. Okay, you're going to look at z equals 0.59. So find 0.5. Scroll over to 0.9 and you get 0.7224. But then you're going to subtract off what you get when you look at negative 1.93. So flip it over to the negative side. Negative 1.93 would be, find negative 1.9 first, and then the 0.03, and it's 0.0268. So if you subtract those, you'll get 0.6956. Okay. So the last question for this one, what if I ask you for outside the interval between z equals 0.46 and z equals 1.75? Okay. So I want outside that interval. So I'm going to sketch this. Remember, like in a pinch, you can always sketch what's going on. So I'm going to sketch this just for this one, just to let you know that you can on all of these. So if you sketch a curve, remember in the middle is always 0 because the z-score is 0 in the middle. And I basically want to go between like 0.46, which would definitely be the right, and then maybe all the way over to 1.75. Okay. So your picture doesn't have to be perfect, but notice here is the window between them, and I'm asking you to go outside, right? I'm asking you to go all of this and all of this. Okay, so logically, how can we get it? Okay, well, we could figure out what we want here, right? And then we could subtract it from 1, right? Because I want the stuff outside of that window. Okay, so basically, we're just going to do 1 minus whatever two values we get from our chart. Okay, so you start at the one on the right. Okay, so find 1.75 first, 1.7. Scroll your finger over till you get to the 0.05, which is 0.9599. Okay, I promise after a little bit you're going to be a pro at reading this chart. Okay, and then the last one was 0.46, so find 0.4 first, and then scroll your finger over to 0.06 and you get 0.6722. Wait, 0.6772, sorry about that. And then you would subtract them to find the area between the interval, but then you're going to take it away from 1 since I want the area outside the interval. So if you do that kind of all in one swoop in your calculator, which you can, you'll get 0.7173. Okay? So really make sure that you pause this video. Like if you're not getting the values, you need to make sure that you're looking up the values in the chart with me as we go. And the good thing about a video is you can pause it, rewind it if you need to, watch it again. If you think I'm talking too fast, as I know sometimes I tend to do, then you should be able to, again, pause it and catch up if you need to. Okay? But really make sure you're actively practicing using the table because that's going to be something really, really important going forward. Okay, so What about this? Find the z-score for which the area to the left is 0.93. Okay? Notice this time I'm asking you to find the z-score, but we are still talking about the area to the left. In other words, in the other problems I gave you the z-score and I said, hey, tell me the area. This time I'm telling you the area and I'm asking you to match that up with the z-score. Okay, so we're looking for an area of 0.93, and just remember that all of these values here are areas. Okay, so you just need to find the one that is the closest to 0.93, and they do go in order. They're not just random willy-nilly written there. So you need to find the closest one to 0.93. Okay, so here's 0.99, so that's too big, right? So we need to go up to where we find 0.93. So here, take a look at these right here that I'm pointing at. There's a 0.9292, and there's a 0.9306, okay? This one's only like 6 units away. This one's 8 units away. So this one is the one that is the closest. So I'm going to kind of circle that lightly so I can erase it later. But this is the closest that you can find to 0.9306. And so then you just read off what the z-score is there. So notice the z-score is at 1.48, okay? So I'm going to say this. The z is approximately 1.48 because we didn't even get an exact value on the chart, right? Okay, so let's maybe write down what we did here. You're going to find the closest area on the chart to 0.93, and you're going to look at the z-score there. Okay, it's very rarely going to be perfect, so you're just going to have to pick the one that is closest. All right, let's do another one. What if I asked you to find the z-score for which the area to the right is 0.14? Okay, so similar question to example 4, right? I'm asking you to find the z-score, but this time I'm saying the area is to the right. Okay, so that is significant, okay, because the chart doesn't read to the right. The chart reads to the left. Okay, so what you have to do first is you're going to have to find the proper area, right? Because it says right, you're going to have to do 1 minus the area you were given. So what you're actually looking for is 0.86, okay? So this is what you're looking for on the chart. Okay, or technically you could look for 0.14 and then know that you need to change the sign. I don't know that. I think that's easier. So again, they're in numeric order, so I'm going to erase the one that I did before. So let's see if I can find the closest thing to 0.86, right? So 0.86, there's a 0.85. This is real close to 0.86. Notice it's only 1 unit off, so I think that's the one we want to pick. Notice here this one's too big, right? It's a lot bigger than 0.86 compared to this one. And so notice that corresponds to about 1.08. By the way, notice that all the values on this side of the chart are between 0.5 and 1. All the values on this side of the chart are the lower end. They're between 0 and 0.5. So the fact that we had values we were looking for, that areas were so big, that's why we ended up getting positive z-scores there. All right, so last but not least, and then you should be able to kind of start practicing your homework on this section. I really implore you to make sure that you have a printed off table. It's really a pain to try to click on the one that's in Math Connect. It's a lot easier if you have a physical table in front of you that you can flip over when you want. You don't have to use your mouse to scroll down all the time. All right, find the z-scores that bound the middle 80% of the area under the curve. Okay, so this one is kind of a higher level thinking question. So anytime you're a little confused about what it's asking for, you can definitely ask me, but try to draw a picture first and see if that helps. Okay, remember a z-score of 0 is always in the middle. Okay, so what I'm asking for is the middle 80%, right? So what I really want to do is I want to cover 80% of the values, okay? And I'm trying to figure out, you know, which one it would be, right? So if I want to cover the middle 80%, then it actually means that this here would be 10%, and so would this, right? Because it has to add up to 1 or 100%, okay? So I don't think there's any question here. We want the area to be 0.8, okay, or 0.80. But that's not how we read the chart. We read the chart as less than, right? So what we really need to know is if we really need to know what is the z-score here and here, okay? Remember, it's symmetrical, right? So once you find one of them, you actually automatically know the other one. It's just going to be the negative and positive versions. So notice if I draw this picture, what I'm looking for, okay? So what I'm looking for, I need to look for the z-score that corresponds to 0.10. Because the chart normally reads less than, okay? So I actually need to find 0.10. Notice that's going to be a negative. That shouldn't shock us. So we need to find the closest thing to 0.10. So here's like 0.11. So notice this is pretty close to 0.10, right? Wait, 0.10, sorry, that wasn't close to 0.10, that was close to 0.01. 0.10 needs to be over here, right? So find the one that you think looks the closest. So these are pretty close. Look at this one. This is 0.1003. This is 0.0985. So this is 15 away. This is only 3 away. So it looks like it's going to be this one. This one's the closest. So again, you can kind of circle it as long as you can erase it once you're done. You don't want to circle it with a pen and then have to, you know, reprint your chart. So notice that corresponds to a z-value of negative 1.28. Okay. So then on the other side, it has to be the positive version. Okay. So in other words, the values that bound the middle 80% are anything in between these two z-scores. Okay, so sometimes you might have to come up with like a brief picture to try to figure out what you've got there. All right, so in this homework assignment, what you're really practicing a lot of is first making sure you remember how to find z-score. Sometimes it's going to give you the z-score, sometimes you have to figure it out. Okay, and then actually, I think in this section, now that I spoke too soon, I think it gives you the z-score no matter what. So I think you're really just practicing using this chart, okay? So just remember, even the picture shows this, but the area is always being told to you from this table, everything to the left. So if you want the area to the right, you're going to have to take it away from 1, okay?